Hello, I'm Jared Hare, an iOS engineer at Livefront.
And I'm Nathan, also an iOS engineer at Livefront.
In this Livefront talk, we're going to be talking about using generative AI for unit testing, specifically in iOS. Before we begin, I'd like to mention that this whole talk was inspired by a blog post from Charles Edge, a local developer and author here in the Twin Cities. He built a tool called TestFairy using OpenAI's API to write unit tests in a matter of seconds, which inspired us to dig into the topic further. TestFairy works by selecting some text in Xcode and then running the extension. It then wraps up that code in a prompt for ChatGPT, which gives back some unit test code that TestFairy then inserts directly into your Xcode project. One limitation of it, as well as most other models we tested, is that it can only evaluate the code it's given, rather than the entire code base.
So what is generative AI and why would we want to use it to write unit tests? Artificial intelligence is the big thing right now, with many uses. It includes chatbots like ChatGPT and Bard, as well as image generation tools like DALL-E and Midjourney, where it uses AI to synthesize an image based on a given text prompt. But another powerful use case is code generation, and that's what we're really going to focus on today. As far as our broad goals and requirements, we have two main questions. First, is it useful? And if so, is it worthwhile? More specifically, this is what we're hoping to get out of it. We want it to write useful, thorough tests, keep proprietary code confidential, have the tests inserted directly into the Xcode project that you're working on, and write tests that are codebase aware, as well as being able to run quickly enough and to be feasible to use in a production environment.
As we mentioned, it's important to keep code confidential, especially when handling client work. There was an article recently about some software engineers at Samsung who had entered proprietary code into ChatGPT, and after being automatically used by OpenAI to further train their AI model, it leaked out elsewhere. We obviously want to avoid that kind of thing happening. And before we get into the models and tools we evaluated, it's important for us to touch on one of the tools we use to interact with the models that we're running locally on our own machines. This is going hand in hand with confidentiality, because when you run models on your own hardware, you can pretty much guarantee that the data you're giving to the model is going to remain on device. Nothing's going up to a server, and nothing's going to be handled by another company. It's all run on your own computer.
The tool that we used for this is an open source tool called Llama. It gets its name from Meta's Llama models, and while it was designed initially to run Meta AI's Llama 2 models, it's since been expanded to run other types of models. It's super easy to get started with, and we ended up interacting with the locally hosted API so that we could actually give it queries, get responses back, and be able to plug those responses into any program that we wanted. We found it to be pretty handy. We looked at some cloud-hosted tools as well as some locally hosted ones. The first and most prominent one is OpenAI's API, which is what powers ChatGPT. This was accomplished using TestFairy, the tool Jared mentioned at the beginning of this talk. The next one here is GitHub Copilot. Copilot usually runs within an IDE that you're running on your computer, but is still interacting with GitHub servers. Locally, we ran those Llama models that we talked about, both the general purpose models as well as one that was fine-tuned for code specifically. We also evaluated two models from Salesforce specifically designed for generating code.
All right, let's jump into it. For these tests, we'd written a fairly basic struct with some protocol conformances like codable and identifiable to be able to test something we might have in a real environment. These are the tests that we had written by hand. We use a setup function for good lifecycle practices, as well as testing those protocol conformances. The codable conformance was one of the more interesting ones to see the AI models try to write unit tests for. Starting with the cloud-hosted models, the first one we tried was OpenAI's GPT 3.5. It's fairly useful overall. Using TestFairy, we could generate code and have it inserted directly into Xcode. As far as confidentiality goes, OpenAI's privacy policy as of December 2023 is that text received from enterprise users is not used for fine-tuning models, though it's important to note the privacy policies can change on short notice. For codebase awareness, the model only receives the text you select, so writing codebase aware tests is not yet possible. Here are some of the tests it wrote. You can see that it tests this formatted date property. For whatever reason, it decided that the current year is 1990, and it also formats it differently than is expected. So that test and any tests that depend on it are going to fail.
This next tool that we looked at was GitHub Copilot. And like we mentioned before, Copilot only runs within specific IDEs. Unfortunately, Xcode is not one of them. So if you want to use Copilot for a project in Xcode, you would have to run a separate IDE like Visual Studio Code to generate the code, and then come back to Xcode to evaluate the test that you just wrote in VS Code. That being said, we found that Copilot is very useful as a general purpose tool, especially for code completion for repetitive or common code. As far as confidentiality goes, the code was not kept for training and commercial purposes, but again, as with OpenAI, it's a black box that you're putting your own proprietary information into and trusting that it's treating your data how you expect.
Now let's talk about these locally run models that we looked at. The first one being Llama 2's 7 billion parameter model. Essentially, the number of parameters represents the quantity of data it's trained with, and we found it relates to the quality of output it generates. Overall, it generates some fairly useful code. Its quality is comparable to ChatGPT, though in our experience, not quite as reliable. With a custom Xcode extension that we made that works much like TestVary, we were able to have it interact with the local Llama API and put the response back into Xcode. It remains confidential because it is all on device, and as before, it's not yet possible to write codebase-aware tests since it's limited to the text it's given. Here are the tests it had written. You can see that it does use the setup function, which is good practice. The rest of the tests are pretty basic. It tries to format the date, but it does so incorrectly because we had specified in the struct that the time should be omitted. The 13 billion parameter model is very similar, but trained on more data. It generated pretty similar, though a little bit more reliable code than the 7 billion parameter model. The hardware is a big limiting factor here. If you have an Intel Mac or not much RAM, it might take a little bit longer or not run at all. Whereas on a newer Apple Silicon machine with plenty of memory, the time it takes will be fairly negligible, just a few seconds here or there. As before, it ran within Xcode and kept the code confidentiality, though without codebase awareness. You can actually see here that this one did not use the setup function. It also didn't try to test the date. The interesting here, though, is that it does try to test coding keys. This is rare among the models we tested. Unfortunately, we had to comment this test out to get the code to build because it does not test it correctly. If you wanted to do this, you'd probably use all cases on coding keys and then test each case's raw value. Another one we tested was CodeLlama. This one was one of the more interesting ones we evaluated because it seems to work better for code than other Llama models. It's also trained on 7 billion parameters, but fine-tuned for code specifically. Unfortunately, it isn't foolproof. This one also doesn't handle the date correctly. But the Codable protocol test was interesting because this is actually the only model that did test it correctly and would fail if coding keys changed. But that test does pass for what it's worth.
The next two models we're going to talk about are from Salesforce. During testing, we got similar results from both of them, so I'll just speak about them both in general. The first one, CodeGen 2, is a 1 billion parameter model. It's pretty small compared to the Llama 2 models we tested, though still sizable. We also tested larger parameter versions of both of these models, though all of them had fairly similar results. To put it bluntly, they generated mostly unusable code. Most of the time, they would give us gibberish or give us the exact same code that we'd actually already given it. It even generated code in other languages other than Swift. Generally, the XGen model was more reliable than CodeGen, but they were both pretty unusable for our purposes. So now let's go back to the beginning and revisit our goals and requirements and see how these tools did. The big questions that we wanted to answer were, is it useful? And if so, is it worthwhile? So, is it useful? Sort of. The results we got in our testing were quite varied, and while we sometimes got interesting and thorough tests, an equal amount of results were almost useless or wouldn't even compile. With that in mind, how worthwhile is it to integrate these tools into your testing workflow? We seem to be right on the verge of these tools really breaking through, but for now, we found that they're best at getting us started, but not for creating a full suite of tests.
Okay, a couple conclusions. Our main one is that generative AI is not yet practical for unit testing Swift code, but it may be in the future. Another is that it's prone to being confidently incorrect or hallucinating, as these AI tools generally are. It can be dangerous if accepted uncritically. Next, code generation is arguably more suitable for use cases other than unit testing. Copilot is a good example in that it's more useful for code completion or boilerplate, and our experience reflects that. Of the tools we used, OpenAI API and the Llama 2 models definitely gave the most usable results. These generated more usable code than anything else that we looked at. And they're much more feasible to use in this kind of environment. And finally, the only kind of instance where this is probably going to be useful is if more unit test focused tools, or even just something like Copilot, is available for Xcode. It's not clear if Apple will add something like that of their own or allow another platform to work with Xcode. So until that happens, the likelihood of something like Copilot for iOS development is not terribly promising.
Generative AI has the potential to be extremely helpful when writing unit tests, even though we don't feel like it's there just yet. With all this in mind, these tools are being developed at a rapid pace, and it's worth keeping an eye on as they evolve.